Welcome to Project Management. In this video, I will talk about project crashing. Crashing is a term for shortening the duration of an activity or project beyond its normal duration. There could be many reasons for compressing project durations. The time to market pressure is one of them. We mentioned this in a previous video. A 6-month delay in bringing a product to market can result in a loss of market share of about 33% for a high-tech company. Another reason is unforeseen delays. For example, 5 months into the project, you realize that you are already 6 weeks behind the schedule for the project. You need to do something to bring the project back on schedule. A third reason is a high overhead cost. It may cost $70,000 per day to just house and feed a construction crew in Alaska. You would want to finish the project as quickly as possible. Some project managers want to finish some project activities quickly because they are under pressure of losing their equipment and personnel to other ongoing projects, which they are sharing resources with. Sometimes, top management make a public commitment for an early product delivery date without consulting the project manager or the team members. The project manager has no choice but reducing project duration to meet the deadline. Incentive contracts are also good reasons for shortening the project duration, so the project team can get significant bonuses for early completion. Let's see an example. In 1994, a 6.8 magnitude earthquake struck the Northridge area of Los Angeles. It collapsed sections of the highway system and disrupted the daily commute of 1 million people. The California State Governor's Office reported that for every day the freeway was closed, it costed the local economy more than $1 million. To expedite the recovery process, the government offered attractive incentives for completing the repair work ahead of schedule. A construction company called C.C. Myers won the contract for rebuilding some of the collapsed interstate highway bridges. They finished the project in only 66 days, which is 74 days ahead of schedule, and earned a $14.8 million bonus. In order to finish the project early, they spent a lot of money on overtime, bonuses, special equipment, and other premiums to keep the job rolling quickly. They hired 134 iron workers instead of the normal 15. Special lighting equipment was set up so that work could be performed day and night. The sites were prepared and special materials were used so that work could continue despite inclement weather that would normally shut down construction. Project managers have several effective methods for crashing specific project activities when resources are not constrained. Several of them are summarized here. We can simply add more resources like people, finance, and equipment to the project to make it go faster. However, be mindful that doubling the size of the workforce will not necessarily reduce completion time by half, unless minimal communication is needed between workers. For projects that involve frequent communication like software development project, Brooks' law may apply. The law states, adding manpower to a late software project makes it later. Another option is to outsource some part or the whole project to subcontractors. The subcontractor may have access to superior technology or expertise that will accelerate the completion of the activity. For example, contracting for a backhoe can accomplish in 2 hours what it can take a team of internal laborers 2 days to do. The third option is to schedule overtime. The easiest way to add more labor is not to add more people, but to schedule overtime. You can avoid the additional costs of training as well as coordination and communication encountered when new people are added. Also, there are fewer distractions when people work outside normal hours. Hourly workers are typically paid 1.5 times for overtime and double for weekends and holidays. Because the pay is much higher, sometimes people treat overtime as benefits and have to compete for it. The high-pay overtime may attract criticism if an organization is running public service business. Watch this video to see the overtime pay in the BART system. Just remember that BART stands for the Bay Area Rapid Transit in San Francisco. Sustained overtime work may incur intangible costs such as health, divorce, burnout, and turnover. It may also lead to an overall decline in productivity when fatigue sets in. Watch another video to learn more about these intangible costs. The fourth option is to establish a core project team with full-time concentration and avoid multitasking. We talked about organizational structure in a previous video. We learned that dedicated teams tend to complete projects much faster. The last option I want to mention is called do it twice. That means we finish the project with a simple solution quickly, and then we make it better. For example, when a bridge is damaged and needs repair, we can build temporary pontoon bridges before the repair on the main bridge is complete. Another example is that we can release software program version 1 and later correct bugs and add new features in version 2. When resources are constrained, there are only limited ways of accelerating a project. The first one is to improve project team efficiency. The project team may be able to improve productivity by implementing more efficient ways to do their work. For some projects, this is possible. But for others, it's easier said than done, especially when employees have already been pushed to their limits. One approach called I bet you seems to work well in improving team members' work efficiency. Let's hear this story. Clark is a project manager and he just received a priority assignment from top management. The engineering sketches that were originally due tomorrow need to be done by 4 p.m. today. So he approached Josh, the team member who is responsible for the task. Josh's initial response is, "That's impossible." Clark understands the difficulty and tells Josh, "I'll make a bet with you. If you can finish the design by 4 p.m., you will get 2 of the company's tickets to tomorrow night's Celtics-Knicks basketball game." Josh accepts the challenge, works feverishly to complete the assignment on time, and is able to take his young daughter to her first professional basketball game. Many project managers use bets like this to motivate extraordinary performance. The bets range from tickets to sports and entertainment events to gift cards to amusement parks and high-class restaurants. The bets have even greater significance if it also benefits family members or significant others. Being able to take a son or daughter to a professional basketball game allows the individual to score points at home through work. The principle behind the story is called the expectancy theory. It works if the answers to the following 3 questions are all affirmative. Question number 1, can I do it? Or is it possible to meet the challenge? Question number 2, will I get it? Or can I trust the project manager and will he or she deliver what's promised? And question number 3, is it worth it? Or does the payoff have sufficient personal value to warrant the risk and extra effort? If the answer to any of these 3 questions is a no, then this approach won't work. Also, one piece of practice advice when applying this approach. Bets should be used sparingly under special circumstances that require extraordinary effort. Otherwise, others may become jealous. When resources are limited, another way of crashing project duration is called fast-tracking. It requires the project manager to rearrange the project network so that some critical activities are done in parallel with the existing resources. One example takes it to extremes. Instead of building a house in the sequence like foundation, then interior, exterior, and finally roof, these components can be built concurrently and assembled together. There are even foldable houses that can be pre-made and then shipped to the customer. Watch this video. Another option is to reduce the project scope. That means certain tasks, deliverables, or requirements will be reduced or even eliminated. Focus should be on changes in activities on the critical path. Otherwise, the project duration won't be shortened. This method may come at a cost of reducing the value of the project and must be communicated with other stakeholders like customers and top management to gather approval. Reducing quality is always an option to shorten the duration of a project, but it's rarely acceptable or used. If quality is sacrificed, most likely you will end up with an unhappy customer and you are putting your business at risk. Watch this video clip from the show Silicon Valley. Project crashing will affect project costs. The general nature of project costs is illustrated in this project cost duration graph. The total cost is the sum of the direct costs and indirect costs. As we mentioned in a previous video, direct costs are those that can be assigned directly to a specific work package or project activity. Examples include labor, materials, and equipment costs. Indirect costs are those that are not directly associated with any particular work packages, but they are linked to the entire project. Examples include supervision, administration, consulting, etc. Direct costs decrease as project duration increases. Indirect costs increase as project duration increases. So in general, crashing a project and make it shorter will increase direct costs but reduce the indirect costs. We would like to crash the project to the optimal duration, so the total cost is minimized. Next, we need to decide which activities to shorten and how far to carry the shortening process. The basic principle is to shorten the activities on the critical path with the smallest increase in cost per unit of time. This is a cost duration graph for an activity. This graph only shows the direct cost associated with the activity because indirect costs are considered separately at the project level. To simplify our calculation, we assume that the direct cost-time relationship is linear for each activity. So this is a straight line, and it's not a curve. The normal point marks the normal time and low cost for completing the activity. In this case, it's 10 days and $4,000. The crash point marks the limit, the shortest time possible with the increased cost. In this case, it's 4 days and $10,000. The slope of the line represents a constant cost per unit of time. It's equal to the rise along the vertical axis over the run along the horizontal axis, or the cost delta divided by the time delta. In this case, it's $10,000 minus $4,000 divided by 10 days minus 4 days. The result means that for each day of duration reduction, the direct cost will increase by $1,000. A steeper slope marked by the red line means it will cost more to shorten the activity for each day. And a less steep slope marked by the blue line means it will cost less to shorten the activity for each day. So when we say we need to shorten activities on critical paths with the smallest increase in cost per unit of time, we mean the activities with the least steep slope or smallest slope value. Now let's see a complete example. This project has 7 activities, A through G. For activity A, the normal duration is 2 days. The normal direct cost is $3,000. The crash duration is 1 day, and the crash direct cost is $5,000. Based on the equation we introduced earlier, we can calculate the slope, and it's $2,000 per day, which is shown in the last column. The calculation of other activities can be done in a similar way. Note that the total normal direct cost of the project is equal to the sum of all the normal direct costs of these activities, and it's $31,000. We assume the project network is already created, and it's shown here. For each activity, we also show the normal duration, crash duration, and slope in the table on the right side for reference. The critical path is ADFG, and it's highlighted in red. The duration of the project is 2 plus 10 plus 4 plus 5 equals 21 days. Currently, the total project cost is $31,000. We need to always follow the rule to shorten the activities on the critical path with the smallest slope first. For these 4 critical activities, G has the smallest slope, which is 0. However, it cannot be shortened anymore because its normal duration and crash duration are the same, 5 days. We use a little cross to indicate that the activity cannot be reduced any further. The second smallest slope is activity A, $2,000. So let's reduce the duration of activity A from 2 days to 1 day. Reducing activity A by 1 day cuts the project duration from 21 days to 20 days. But it also increases the total direct cost by $2,000, from $31,000 to $33,000. We put a little cross to indicate that activity A cannot be reduced any further. Now we need to check if ADFG is still the critical path. Turns out it still is. Compare D and F. Activity D costs $2,500 to shorten, and activity F costs $3,000. Activity D costs less. So we reduce the duration of D from 10 days to 9 days. The duration of the project is further reduced from 20 days to 19 days. The cost of the project is increased by $2,500 to $35,500. Now we have 2 critical paths, ADFG and ACFG. In order to reduce the project duration, we need to reduce C and D together, which costs $5,500, or just reduce F, which costs only $3,000. So we reduce the duration of F. The project's duration is reduced from 19 days to 18 days, and the total cost is increased to $38,500. This move has created a network with 3 critical paths. The third one is ABEG. All activities are critical now. To further reduce the project duration, we must reduce the durations of both C and D together with one of these 2 activities, B and E. Because E is cheaper, so we decide to reduce C's, D's, and E's durations. Now the duration of the project is 17 days. The cost of the project is $47,000. We still have 3 critical paths. However, none of the activities on the critical path ACFG can be further reduced. That means we already reached the limit for this project network. Although some activities like B, D, and E can still be reduced, their reduction will not result in a shorter project duration. Let's summarize the project duration and direct costs in this table. The duration is reduced from 21 days to 17 days, and the direct cost is increased from $31,000 to $47,000. We assume the original total indirect cost is $40,000, and it will be reduced by $5,000 as the project duration is reduced per day. The total cost is equal to the direct cost plus the indirect cost. So when the project duration is 21 days, the total cost is $71,000. When the duration is 20 days, the total cost is $68,000, etc. Finally, we find out that the lowest total cost is achieved when the project's duration is 18 days, and the total cost is $63,500. We plot that relation in this cost-duration graph. It's more straightforward, and we can quickly find the lowest point in the total cost curve. Further reduce the project duration to less than 18 days will increase the total cost. In this example I just showed you, we only used one criterion to decide which activity to shorten. That is, to shorten the activity on the critical path with the smallest slope. In real-world applications, the choice of activities to crash and how far to go rely on many other factors as well. The logic of the cost-duration graph suggests managers should reduce the project duration to the lowest total cost point. However, compression of a project with several critical paths increases the sensitivity, reduces scheduling flexibility, and increases the risk of delaying the project. The practical use of such analysis will probably suggest only a partial movement from the normal time towards the optimal time, so it doesn't push to the edge. Another factor that needs to be considered is that crashing an early activity may be ineffective. This is because sometimes subsequent activities are likely to be delayed and absorb the time gained from crashing the earlier activity. Sometimes the resources required to accelerate a cheaper activity may suddenly not be available. If the least cost method repeatedly signals a subgroup to accelerate progress, fatigue and resentment may set in. On the other hand, if overtime pay is involved, other team members may resent not having access to this benefit. So far, we have been talking about project crashing in terms of time. It's also possible to do project crashing in terms of the cost. Organizations are always looking for ways to reduce cost and get things done cheaply. Cost overruns create unhappy customers and can damage future business opportunities. One commonly used option for cutting costs is to reduce project scope. For example, on over-budget movie projects, the director may replace location shots with stock footage to cut costs. Sometimes, cost savings can be generated by extending the duration of a project. This is just the opposite of what we have been doing, shorten the project time with higher cost. A smaller workforce, less skilled labor, less expensive materials, and cheaper equipment. We may also ask the customer to take more responsibilities. For example, we may identify tasks that customers can do themselves. Homeowners frequently use this method to reduce costs on home improvement projects. It's advisable to negotiate with the customer before the project begins. And this is only limited to areas in which the customer has expertise and the capability to pick up the tasks. For example, a homeowner may agree to paint the room instead of paying the contractor to do it. But the owner may not be able to do plumbing and electrical wiring, which require professional qualifications. The project manager can hold a brainstorming session to solicit cost-saving ideas from team members or other stakeholders. Project managers should not underestimate the value of simply asking if there is a cheaper, better way. Outsourcing project activities or even the entire project is also an option for reducing cost. Many American firms outsource work to firms operating in India, where the salary of a software engineer is one-third that of an American software engineer. Outsourcing customer service call centers to overseas can lead to a saving of 60%. Watch this funny parody news video about outsourcing. When the project is outsourced, you have less control over how it's completed. Therefore, you will need to have clearly defined deliverables. Just beware that there are also downsides of outsourcing. Watch the second video about this. In summary, we talked about different options for reducing project duration and cost in this video. This is Wang. See you in the next video.